Welcome to chapter one, and chapter one, we're going to talk all about solving problems, all right, and this thing called critical thinking. So, the specific thing we're going to talk about in section one is inductive and deductive reasoning. So, these are fancy terms, and you probably have been exposed to these terms before, especially in geometry. So everybody should have taken geometry before, and should be a review from that. We got two things that we're going to try and teach you. They're both related to inductive and deductive reasoning. So I'm just going to leave this up on the screen here for a sec. You can take a look at it. But basically, inductive reasoning has to do with looking for patterns. We use this all the time whenever we're in a situation as human beings. Maybe it's a new situation that you haven't been before. Oftentimes people stand back, they look around, and they think, I wonder what everybody else is doing. You watch what everybody else is doing, you figure out the pattern, and then you go ahead and do it yourself too. In mathematics, these are like the 2, 4, 6, what number comes next, and you should say 8. That's inductive reasoning. That's a pattern. It's going up by 2 each time. There's two words in there that you're going to see in the work that we're doing: conjecture or hypothesis, and that is in the example I gave where I said 2, 4, 6, what number comes next? 8 would be your conjecture or your hypothesis. That's your best guess as to what's going to happen. And then there's a counterexample. So back, a couple thousand years ago, people thought the world was flat. And they thought it was flat because of what they observed. And they also thought that the sun went around the earth because that pattern of the sun coming up in the east and setting in the west made them think that the sun went around the earth. So all you have to do to prove something like that wrong is come up with a counterexample. And so for the earth is flat, people got in boats and they sailed around the world, and that proved that the world was in fact not flat. So these are some examples of inductive reasoning. You might see some problems like this in the work that we're going to do. Basically, we're going to have two assignments. We're going to have, I'm going to break the assignment into two parts for you. So you can see this is more like the story problem here. Lots of numbers. You have to figure out what's appropriate, accurate, what's there just to trip you up or confuse you. I won't worry about that too much. This is a weak inductive argument because it says men have difficulty expressing their feelings. Neither my dad or my boyfriend have cried in front of me. So a weak inductive argument is one that does not have a lot of data behind it. In other words, a lot of chances to observe any patterns, right? So if this person observed two people and then made a conjecture based on that, that's not a very strong sample. So these are more like the number problems that I was talking about. So you're going to see problems like this in your homework. You see 3, 12, 21, 30, 39. Well, it's going up by 9 each time. So our conjecture here is 39 plus 8, which is 48. And here's another example here. This one is a pattern that it's being multiplied by 4 each time. So obviously this would not be given to you, so you have to figure that out. All right, but this is still inductive reasoning. All right, and now it says 1, 2, and 4. What's the next number in the sequence? So this one's a little bit confusing because actually both of these are correct, right? Because if you're just adding 2, then the answer would be 6. The conjecture would be 6. But if you're multiplying by 2, then the answer would be 8. So you can't really figure it out based on inductive reasoning. I think this is just another example, something that you might see. If you want to, you can pause the video and you can check that out. Here we go. This is what I wanted to get to. Some of the patterns are going to be visual. which I like a lot because not everybody is all keened in on numbers and hyped up on numbers all the time. So you're gonna have some problems like this. So what would come next in the pattern? So there you have it right there. That would be what comes next in the pattern. All right, we're going to move on real quickly now to deductive reasoning. So deductive reasoning, if you took geometry, you probably didn't like this very much because this was the proofs. Now, don't get freaked out. We're not going to do some proofs, but I just want you to know that in your life, you're going to have problems. You're going to have to face problems. You're going to have to deal with problems all the time. And the best problem solvers can handle using both of these types of reasoning. Maybe you're in a situation where, looking for a pattern just isn't going to help you. And that's the case, then you have to use deductive reasoning. This is where you're really logical. You have an explanation for every point you're trying to make, and you kind of go through and you prove to somebody that your answer is the correct answer to the problem. Here he says, one player to another in a Scrabble game, you have to remove those 5 letters. You can't use Texas as a word. And the exclamation, or sorry, the statement that is put in the format of deductive reasoning is right here. All proper names are prohibited in Scrabble. Texas is a proper name. Therefore, Texas is prohibited in Scrabble. So that follows that nice logical pattern there. If you look at this right here, you see these are like examples from algebra, right? And if you look at this right here, this should look familiar to you from algebra. And basically, you can go ahead and you can justify each one of these steps, right? And so, by justifying each one of these steps, then you're using deductive reasoning, breaking it down logical step by step, explaining every single step. That's deductive reasoning. So that's the big ideas for Chapter 1, Section 1, Inductive and Deductive Reasoning, and we'll try out some problems from the textbook.